Yeah. Testing, 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 testing. Will you copy the new link? Yes, now. Yeah, see, maybe it's working. Disable it. Is it working? It's not. Hello, 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 hello. Is it working? Oh, clearly. Oh, can you hear me? Are you sure? That's the whole heap of pieces on my shirt. Working? Oh, Hello, 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 hello. Abigail, wait, I think maybe that one because maybe the battery is low. Yeah.
Oh, what's the name of this one? Coffee. How does it connect to the mobile Africa? Hmm. Yeah, I need to connect it to the prayer network. Oh, okay, okay. Network. I don't know what's going on. Where's your remote for this? I need to change your network. It's lagging. I'm not displaying what's there. Yeah, that's what I'm trying to do. The network here is lagging. Faisal, I'm sending to you. Is my Teams on? Let me see. Let me see my Teams. I don't think it's still on. Have you received it? I sent a link. Oh, damn it. I sent it to someone else. Teams. Can we switch the network to be a client? The whole wallpaper is buffering, so it's costing me each. No, no, no. This. Like the one on the TV. Yeah. Okay. Yeah, good to go. And it's scribble with the smart board. I shared it with Faisal already. I don't think you necessarily have to download it. So we're good. So let me know. Right, just before we get, we're waiting for them for the live stream. Hello, my name is Philip Nkwam, and just briefly, can we introduce ourselves and make it more bubbling in some sense? I can start from here. No, you don't need to. Oh, you're not in the classroom. Yeah. Morning. Okay. 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 Interesting. Interesting. But before everybody continues, first apologies for this starting late. Right. Needed to do that first. Yeah. So yeah. Perpetua is a nurse. She works in the hospital, but then she's in the data analytics track at 3MTT. That's for Perpetua. And then yeah. Hi. No other Lola. Okay. 3MT also. Okay. What track? 3MT? Oh? What track? Project management. Oh, interesting. So the project management dudes want to know how AI works, and then they can easily bring themselves into it. Yeah. Morning. Oh, interesting. Okay. Nutrition. Okay. Mhm. Mhm. All right. We're moving towards um what we call uh more or less like cyborgs. So are there like plant nutrition for cyborgs? Cyborgs, I mean humans infused with um intelligence. And so, for example, there's a name we call them. It's a concept called transhumanism, where instead of people having normal hands, right, just conventional hands, you can actually have a hand that does so much more than a normal hand. So then nutrition plans for that. So I was just looking. Yeah. Messi. Okay. When, okay. Is that Afri?
What is going on, guys?
Sorry.
If you
Okay. 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 Oh, you feel it, well? Oh, interesting. JavaScript. Okay. Okay. Interesting. Yeah. Oh, yeah. Okay. Okay. JavaScript also. Okay. You sound so much like a Chinedu that was on my track when I was taking data guys at Whoa. Yeah. That was it. See. Okay. So, AI beginners. Okay. My family people. Yeah. Mhm. Cybersecurity. All right. Okay. Cybersecurity AI. JavaScript, biochemistry. Yeah, I know. I'm a health person, so I'm motivated towards that. Project management and then analytics. That's interesting. That's interesting. My name is Philip Mokam, like I mentioned earlier. I do AI research core. Um, research. Yeah. So, but then it doesn't mean I'm collecting surveys on what people think about AI. That's not AI research. So, if I'm going to go into that just before we go into the technical stuff, and the entire thing about this class, you don't need to have any knowledge. Okay, I'll try to simplify it as much as I can. Right, trust me with that. But then just before that, when we talk about AI research, what do you think? Just before I mention my own perspective. Yeah, it's a random, can be a random answer. Anybody. What do you think when you hear AI research? I mean, you probably have heard it before, right? Have you heard anything AI research before? You heard about AI, you heard about research, but not the two of them together. Interesting. So, like, at least does anybody has like anything on what they think AI research is? Sort of, but that wasn't really precise. I think I have like a pretty idea of it. Anybody, I can try. Yeah, explorative. Yeah. So yeah, it has a very sort of good idea of it. Uh, essentially, when you look at OpenAI team, so for example, look at OpenAI team, you realize that most of the engineers there in quotes. Is my mic working? Is light set? You can't answer anything. Ah, it's running a watermark. Maybe a watermark on it. So the problem is it showing on your hand? Let me just add you. What's your file? Are you seeing my interesting? This is another AI mimicking Omniverse. If I saw FAESOL, yeah, can you? Is it correct? Um, I didn't even know that. Correct. Let me see. Yeah, it is correct. So yeah, you should have access now. Okay. So I was saying something. I was saying something about don't worry. By the end of this session, you I promise you think you know AI. You think you should be working in OpenAI already. But let's see. When you look at the team at OpenAI, you notice most of them are PhD guys. Just take out some time and look at the OpenAI website. Wherever you can actually find their team, their core engineering team, you realize that a bunch of them are PhD guys. Essentially why? Like why do you think you have lots of PhD guys on your team? Yeah, essentially research. Right. So these people have probably worked on generative models when they were in uni for their PhD, a whole 5 years working on generative models, diffusion models, um, just different concepts. And then they come together to now build based on whatever they found, right? So AI research essentially is, aside innovating in quotes, we are taking existing systems. So, for example, the AI engineer, in quotes, AI engineer, many of them just take already existing models, right? Or already existing workflows, more or less like this is how we approach this is how we approach classification. And so there's a code on classification. There is a way we do classification. So the person does not necessarily have to innovate anything. All he has to do is to write the code, implement with data, and get what they need. That's all. But now people have actually morphed so much so that you just take an already existing model, probably your login phase, right? And just maybe fine tune it and then deploy it into production, then feed it to your customers. Do you understand? So, for example, you have, let's say, pitch.ai now. There's an AI functionality there, right? So, basically, they take either OpenAI or Mistral or Coin, any of these guys, take their model or even connect to their API, not necessarily their models, okay? So, that's AI engineering in quotes. But in AI research, we actually want to, we are thinking, how can we improve the already existing models? How can we improve the performance? So, for example, in a segmentation task, let's say this room, when you take a picture of this room, and I want to segment him, okay? I want to segment this guy away from everybody. Or you've probably seen the iPhone, when you take a picture, you can remove whoever is in the background. Yeah. So that's more or less like an instant segmentation. And so I want to segment him away. The previous conventional way of doing segmentation might not take him outrightly, might even sort of take him away, but the his own background in the picture is still a bit, it's not looking real. So AI research essentially is we want to think how can we figure out stuff to make it get better. That's what research is essentially. So when we talk about DeepSeek R1, DeepSeek V3, how they did something that turned everybody head upside down, right? It was entirely AI research. And if you look at the DeepSeek team, majority of them were PhD guys, just young PhD folks coming together, experimenting stuff, and then doing really amazing things. Okay, do we get it now? So essentially, that's AI research. Any questions at all before we start proper, or you want to understand whatever I just said deeper? Mhm. Yeah. Mhm. 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 Yeah, well, you might be able to. There's a bit of thin line between both of them. On GitHub, you are more or less contributing to an already existing source code, right? So you found a bug, you found a problem, or you notice it lags a bit, then you modify and then you contribute to the source code. But in AI, let me use a simple example. Um, I want to do, I have, okay, for example, when OpenAI released GPT-2, 170 million parameters, right? So they realized that they released a paper, was it 2015? Few short learning, yeah, few short learning and language models, I think so. Hey, Jesus. All right, they released a paper, few short learning and language models. And then their existing GPT-2, which was doing pretty well then, before everybody knew GPT as a language model, right? It was doing pretty well, 117 million parameters. What parameters? Sorry. What parameters mean is when we are training a model, we save some certain things, the weights, the biases. I'll go into that later. But parameters essentially mean in our training process, we save some things that are regarded as a body of knowledge when training that data, right? So we save them in form of parameters. So they realize that the larger the parameters when they are training, right, the larger the um what I say the complexity of the language models. So for example, before you could only solve assignments, but now we realize that when we increase the number of parameters, we found out that it cannot just only solve assignment, it can actually solve mathematical logics. It can actually recommend stuff for you. It can actually do lots of other things. It can actually interpret for you from this language to the other. Okay? Because essentially the background was as a language model, what are you doing? I'm taking this is my I want to say, okay, let's say how are you? Okay? What we're doing now essentially with the language model is we are breaking we want we want the language model to think and talk like a human, to give responses like a human, right? So we have how are you? Okay? If you fix how are into a language model for the language model to complete it, I'm telling you essentially how LLM works. So I break these three things into what we call tokens. Okay? I have a bag of words before I can make any sense of them. Because machines think in numbers, they don't understand letters. Okay? So how do we break everything in such a way that they can actually understand as numerical patterns? And so I break how are you into three tokens. Okay? There are some words, there's some body of words that are not necessarily they can be regarded as one token. For example, I can say let's say mainstream mainstream media. If I didn't write that correctly. Mainstream. Instead of the language model taking it as one word, it breaks it into two tokens. I'm just trying to give you an idea of what we call tokenization in LLMs. And so I want to ensure that all of these things, I convert them to numerical patterns. But before I do that, I break them down into tokens and I assign a probability number to them. Okay? I break these words into tokens. And in the bag of words, there are lots of words that have different probability numbers. And so I attach, this is a token also, I attach a probability number to them. So much so that if I say how hard, so many words the language model can actually bring next. It's a generative model. So I'm saying how hard. The language model is trying to figure out what does it mean. If I'm telling the language model to complete the sentence, what do you think it will do? What it does is, since there are lots of words in the world, right? It assigns a probability of occurrence to each word. So for example, you, them, we, her, for. The probability of you occurring is 96%. Probability of them occurring is more or less like 0.2%. Probability of we occurring is, let's say, 1%. Probability of R occurring is 0.03%. Probability of 4 occurring is 0.001. So you assign the probability number over 100 to all the words, and then it returns the one with the highest probability of recurring. Does it make any sense? I put in, that's how it understands, that's how it infers, that is, it returns results. And so, how are you? If I remove you, and I tell the language model to figure out the next response, what does it do? It assigns a probability score to every word in that bag of words, and then it returns the highest probability. So in essence, you can just call an LLM a probabilistic model because it works on probability. Do you get it now? Probabilistic model. It works on probability. Okay? And so no matter that's how, so imagine this how are you for a whole full textbook. So when you train a whole full textbook and it breaks the entire textbook into tokens, right? It learns how words reoccur together. It learns how words reoccur together, how they work together. So for example, the LLM has learned that my name is Philip all across the textbook, right? By the time it sees my name is, it knows that Philip has the highest probability of occurring based on what it was trained with. Do you get it? And so it will assign Philip as maybe 99.9% and every other one 0.001, 0.001. Do you get it? Is it a bit clear now or you want some further clarity about it? Do you get it? I'm getting a lot of no like, oh, what's he saying? What the heck is he saying? I can take my time. Yeah, yeah. So again, I want to train a language model. And so I give it a bag of words. I give it a textbook, more or less. And in that textbook, there is a recurrence of word. Like there is a way words are placed together. But in the textbook, um, um, I'm seeing uh, what's the is it butane? I'm saying butane is the smallest alkane group, right? Is that correct? I think you did organic chemistry in school now. Butane, yeah. Methane, yeah. Bu is two. So methane is the smallest alkane group. Now, if you see methane is the smallest dash, okay? Based on whatever it has learned, it will attach the highest probability of occurring towards alkane. So methane is the smallest. If you learned in the textbook that alkane, yeah, the smallest alkane group, the next probability word is alkane. How does it work? He assigns based on the training pattern after he has learned from the textbook. He assigns the highest probability of occurring to alkane. And so in the textbook, you can have alkane, you can have alkene, you can have alkyne, you can have chemistry, you can have messy, right? So it returns the lowest probability for messy. It returns the highest probability. Do you understand? He assigns probability to them based on what he has learned and then gives you the one with the closest probability to the preceding word. Is it a bit clear now? So like this is more or less the foundation. So when they did GPT-2, they realized that okay, this was what they were targeting, bag of words. And then they realized that even after the model learning how to do things this way, when they saw like a complexity of data with more parameters, I think they scaled to I think 600 and something million parameters. That's more weight and biases. The model got bigger. So they realized that the more we increase the model size, the parameters, the more this thing thought in a complex way. Do you understand? So that's an example of research. So we are finding out something new by modifying certain things. So we are not particularly increasing functionality like your community to a gig of code or you're trying to reduce inference time or anything. Reducing inference time sort of if you are finding out something new, right, is also research. So the entire thing about research is we want to find out something new, right? We can enhance an existing system in some sense without finding out something new. But in research, we need to find out something new. If it's not new and it's conventional to the community, we don't need it. That's the essence. So I say I'm an AI research scientist and you're finding out that whatever you did, whatever you built, whatever you modified, is not doing anything new. It's probably someone else's work, and then you're more or less like replicating it, the same thing, the same result. It's not new. But if you can actually find out something new, you realize, okay, this is AI research. And that's what we see with DeepSeek. We realize that many of the things they did, they built on other people's work. From literally, and the entire thing, we'll go there, we'll talk about it. The entire thing they did, whatever they added to the complexity of the system, they used other people's work, but they found out something new. Right? They had a couple of funny discoveries. All right. Any questions at all before we start? You're wondering how we haven't even started. Yeah, there's a lot to talk about, and I want to ensure that you leave here very, very full and ready to. I mean, one of my okay, the goal for this essentially is by the time you're done, you should be able to have conversations around this space, right? At the basic level. So she's a nurse. I'm in my clinic. How do you think I can improve the workflows? How does research or AI research intersect with what I do as a biochemist, project managing manager, product manager, and all sorts. Yeah, we had some people come in near me. Can you please introduce yourself, Victor? Okay. The both. Okay. Okay. Uh, Femi. Yeah, are you Femi? You're one of those guys they complain about on social media. Okay. 3 MTT, what track? Data science. Okay. Okay. You have a Femi in this class. That's amazing. Femi, be careful. Alright. It's a joke. So yeah, we want to start with. Oh yeah, you're hiding. Alright. What's the name? Ev- Eddie. Okay. Um, JavaScript Go. So interesting. So they are your track members. Oh, you don't know them? Ah. Okay. It can't happen. When I was having my session, yeah, nah. You probably would have been families already eating together. Great. All right. So we want to talk about. So first thing first, did we hear about DeepSeek, or you just saw one jargon on a social media page or adverts, and this thing looks deep because it's DeepSeek. So I'm seeking deep, and you thought to join the class. Did we like hear about DeepSeek? I think I should give everybody the opportunity to talk. Yeah, yeah, first. Nvidia tanked. Okay, okay, okay. But you didn't like essentially know what DeepSeek was at the time. You didn't know. Interesting. I'm doing this so I know where to start from. Okay. 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 Yeah. Let me see. Yeah. Yeah. Mm. Mm. Mhm. Interesting. Interesting. Anybody else? I think everybody must talk. Everybody must talk. So I know where to start from. Okay, you just saw it like on an advert or like it was sent to the community. You just saw DeepSeek, yeah, and you saw AI. right? Damn. CNN. Oh, I thought you saw the advert of CNN, right? Okay, you saw DeepSeek on CNN. Yeah. Okay. Yeah, basically they were talking about DeepSeek on CNN, and then they were comparing. Okay. Next person, everybody must talk. Femi, you too. Femi. Okay. Okay. Sure. Genius. Okay, interesting. Um, next, I want to know so we know where to start from. So, okay, I just saw it somewhere. I just thought, oh, I don't know anything AI and everything. Heavy. Okay, cool, cool. Victor, like, do you know anything about DeepSeek? Okay. But yeah, so I know where to start from now. But we know OpenAI. We definitely used GPT before for your resume and your application. Are we sure? Exactly. Uh-huh. I have very honest people in this class. So yeah, we know about GPT for precisely because that's what's free. Um, however, the essence of talking about DeepSeek essentially is we realized that when DeepSeek was released, when DeepSeek was released, the claim was it it outperformed GPT-4. That was the claim. That was why there was a rave on social media, right? And not just that, they realized that GPT-4, you can train GPT-4 with over, let's say, 100,000 GPUs, right? I'm training DeepSeek with just 2048 GPUs. I'll explain what GPUs are further. But just imagine I'm training GPT-4 with 100,000 M1 max, right? And then I'm training DeepSeek with just 2048, and then it's giving me a better result than not even GPT-4, GPT-01. I'm going to explain that. GPT-01 is OpenAI's reasoning model. Let me explain that. When GPT-4 was released, GPT-40, it was just a language model. And so there was a goal. If you can make a language model reason, that is, regurgitate its own responses, not just, oh, this is a bag of word, this is what I found out, and then dishes it out. If you can make the model look at its own responses, evaluate its own responses, modify its responses before giving out the final response, we are achieving something great in language models. And so the pain point was if we can make any language model, we know what language models are already, right? No, right? You 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 don't. Good. No. This class, if there is a no, your no should be louder than your yes. Yeah, it shows you're learning. Language model. Let's use Google to help ourselves. What's a language model? Can you say it? In very simple word, a language model is a machine learning model that analyzes and predicts what language. Okay? And then on what basis uses what statistical and what probabilistic technique to determine the likelihood of a word or a sequence of words occurring in a sentence. So whatever I just explained a few minutes ago, right, is actually what we call a language model. Don't let anybody bubble you. It's not as technical as it sounds. Okay? And so a language model is basically a machine learning model that for those that were just coming, we had explained how like language model works, LLM works. And so we look at the sequence of words. We want to see how well it would predict the next word or the next sequence of words based on what? Probability. And like I said earlier, when you are training, you are assigning for, let's say in a book, right? The language model takes everything, breaks them into tokens, understands that, okay, in this book, this is a sequence of words. This is a sequence of words. By the time I'm testing that model, I trained it already and I'm testing it, right? What it does is it assigns probability to each word attached together. And so they call it the likeliness of showing up. And so, how are you? If I say how are, if I feed in how are, and I want it to return the next word, you has the highest probability based on what we have trained it with. If we train this model with how are they, let's say the entire data we trained with had how are they has the highest probability of occurring. Do you get it? So because the model already learns that if I on those books I'm training with, I have how are you. So that means how are the next word based on what I was trained with has to be you. So he assigns the highest probability of occurring towards you. I put it here. So for example, we have you, then we are for 96% goes to you, the highest probability of occurring. And then every other one has a good probabilistic percentage, but then a way lower. Okay? That's how it works essentially. That's what we call a language model. Language model. Model that interprets and predicts language. Do you get it? So where are we coming from? Before I got into language models. Huh? Very good. Yeah, she was following me. So we started from, yeah, I was talking about reasoning in O1. And so we do not want the language model to just, oh, bag of words, give us the next probability of word and everything. And like I mentioned earlier, AI research, the more you innovate, the better it becomes. You're finding out something new. So the goal, as at last year or 2 years ago, was if we can make the model reason. Let me give you a simple example. Um, so let's say I want to take this. I activate my okay, O3 is fine, and I say what what do you think about my students at the Bob Africa? A very abstract, ridiculous question. You see something, you do something first. Look at it. There was a reasoning. Okay, let me make it easier. Alright. So I want to use the DeepSeek model, distilled, and I say, can you draft a recommendation letter for a PhD program in um, a PhD program in, I'm looking for a economic complex. Um, let's say symbolic systems. Can you see? A whole 24 core GPU in yeah, symbolic systems. You notice if you use GPT-4, the reasoning is not part of it. It doesn't reason. You don't see that emphatically. But let's see this. whatever is loading, present prompt, let's hold on a. Yeah, thinking. Can you see it? GPT-4 doesn't think. So when reasoning essentially is, he understands what he wants to do. He has a body of response he wants to give you, but it doesn't just give you. He regurgitates about it. He thinks, okay, these are the loopholes in my response. Do you understand? This is a better way to address this. Oh, since he wants to do this, let me approach this in a different way. When you look at the reasoning pattern, he says, all right, so I need a draft recommendation for a PhD writing system. Where do I even start? She she doesn't just returns, oh, da 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 da, dear sir. Do you understand? So we wanted to 2 years ago, stroke last year, we wanted to achieve, if we can make it reason, that means it can be better. The responses can be actually much more tailored and better. And so we see, he says, where do I even start? So first off, I guess I should understand what exactly a recommendation letter entails. Then he says, from what I know, it is a formal document that speaks highly, lowers someone's reputation based on their work and character. So he says, so the user is likely someone who has worked with me before, maybe in my academic or professional capacity, and they want to recommend me for a PhD program in symbolic systems. And then he now says, oh, what exactly is this symbolic system? So he says, symbolic systems usually deal with areas like artificial intelligence, cognitive sciences, linguistics, or something similar. Okay? And so he tries essentially to figure out how exactly he wants to go about the task. Can you see it? Then finally, give us the recommendation letter. Can you see it? And so the goal was, how can we figure out reasoning in a language model? That was 2 years ago. So that was why OpenAI released O1. So OpenAI released O1, I think last year. I can't remember exactly. Then, yeah, O1 was their best performing. And so when you look at the benchmark, based on Scale AI, you realize that O1 has been great, has been around. Enigma evaluation. These are different evaluations. So what this means essentially is we take the model and we test its performance on various tasks. And then we create a leaderboard, the best performer in quotes compared to other models. And so we see O1 has been doing pretty well, pretty well. GPT-4 is nowhere to be found. O3 mini is fine. Right? O3 mini was the one given that response on GPT. O3 mini is fine. Well, let's try. Now, we did that on DeepSeek. Let's try on O3 mini. The same thing. Should we try that? Let's see. With the question we asked, we did it on DeepSeek. That's Llama. Sorry, Llama Studio. This the model that gave this response was DeepSeek R1, distilled Quen. And so let's take this same question and ask O3 mini and look at the reasoning pattern too. So we look at O3 mini and say, can you? Now the problem is O3 mini doesn't give the user the opportunity to look at the reasoning process. And so you realize something. Did you see? Did you find out something? I'm not talking about the response. Did you observe something compared to the DeepSeek we ran a few minutes ago? If if you can get it, well, it did reason for a couple of seconds. But let's compare that to DeepSeek. Huh? He said, yes, yes, good. You realize that in O3 mini, the reasoning was shorter. The reasoning was shorter. And we're pretty much already going into the DeepSeek paper now. The reasoning in O3 mini was shorter. It reasoned for a couple of seconds. But reasoning now, if it's getting really technical, just do a pause and say, hold up, stop here, and let's go through it. Because we'll be entering different quarters. And so you have reasoning, right? This is what we had. This is shorter. DeepSeek, right, is longer. Okay? And so when they implemented reasoning in language models, O3 mini, O1 reasoning time was shorter. Another word they call it chain of thought reasoning. Chain of thought reasoning. It's as simple as it is. Don't complicate it. Chain of thought, the way I think, reasoning, right? And so we see something here. Oh my God, where is this going? Um, trying to get the exact paper. Okay, give me a second. I want to get the opening DeepSeek run paper and then I show you clearly. And so in O3 mini and O1, we had a shorter reasoning time. Are we together? In DeepSeek, we had a longer reasoning time. That was one of the things they achieved. They said if you can extend the chain of thought reasoning, right, it will improve the performance of the model in complex tasks. Okay? That was one thing that beats GPT. And so in O1, the reasoning time was very short. O3, you can see it very short. Then they observed when these guys released whatever they did, the chain of thought reasoning time was longer. Okay, it was a problem. Like it was a problem in the research community too. How can we extend reasoning time? And so they could not. They could only scale it for a shorter time, right, based on the GPUs they have. And so the aha moment was they didn't use so much GPU yet they were able to extend it, for reasoning time. And let's bring it practical. If I give you an exam, right, the person who takes time to think it through, right, a complex task, the person who takes time to think it through has the highest probability of giving a better response. At least if two of them are intelligent people, right? The one who takes time to think, I mean, at least you learn slow to speak, slow to write, quick to hear, right? So the one who is calm and takes out time to think and then say something has a better response in quotes. But the person who, hey, what do you think about what's the calculation of quantum this says B1? No, there's a shorter reasoning time. So the problem was how can we extend auto reasoning so much so that language model can be better? That was what DeepSeek, one of the things they achieved. Okay, and so I'm learning to use my slide. So first, we want to talk about we'll go back into this. Let's follow the thought process. We have been. Has anybody heard about ANIs, AGIs, and SIs? This class is better with questions. It's always weird when, because you probably sleep. Yeah, like I efficient, effective learning to me is question based. Especially when I know that some people saw it on CNN, right? Some people saw it on CNN. So I'm expecting lots of questions. So I'll know that, oh, you got this, you didn't get that. Because that's what makes lecturing effective. If I've been talking and then you're just okay, let's just finish it. Do you understand? So I'm actually expecting questions for me to be comfortable that you're learning. And so have you heard about ANI, AGIs, SIs? Has anybody heard about it? You haven't. For the project managers, for the managers, all of you eventually, you're already using this without knowing. And if you don't know how to use this better, there was something I said lately that um, people think AI is going to replace people, right? Do you believe so? You don't believe so? Yeah, I'm a married guy. Why don't you believe so? Okay. So you mean like especially in marine logistics, right? Medicine, like AI can replace the doctor. Good. Okay, how about you? Mm. Yeah. Yeah. Yes. Okay. So he believes humans would usher artificial intelligence. He believes AI cannot take some jobs, right? He believes AI cannot even do well in medicine. Yeah, cannot take good, right? So there are two, and it's going to be the foundation of what we're doing. Do you want to say something? I think you should say something. Yeah, yeah. Okay. How to? Good, good. Anybody else? Dami, you want to say something? Same thing. Perpetual? Something you want to say? Okay. Some, okay. Yeah. Yeah. Good. 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 All right, very divergent perspective and very interesting ones. I'm always very particular about the most difficult task. So do we think AI can actually do the most difficult, especially when it comes to manual labor and everything. But then it gets really interesting because technology will always be technology, right? Some people will get it later, some people will get it earlier, right? Some people in marine, everything, they probably will get it maybe in like 20 years time, right? But in the US, you can they probably already using some of these things in some regions, right? But yeah, let's get to it. AI is going to you said medicine. I promise you it's going to. Do you know why? Because that's my field. And he thinks better than doctors. Oh, you don't know? That's one of the doctors in Lutz use ChatGPT to diagnose you if you go there. Replace them. So the narrative is AI is never going to replace people. People who use AI will replace people who do not use AI. That's the narrative. Yeah. And so if you, and the essence is technology, always have this background. When you want to think about disruptive tech, technology will always be assistive. It can never be at the forefront. Technology will always be assistive. That's the basis. So have that basis that either AI or either that thing can kill humans or whatever it is, whatever they innovate, it will always be assistive, right? And so you see, for example, in medicine, right? Um, in the lab, a lot of people focus more time on finding protein sequences, right? They want to know, oh, because that's the underlying thing of diseases and everything. But now you don't need people in the lab essentially to do that. You still need people in the lab, but you don't need people in the lab to do that particular thing, right? You can actually use there's something we call alpha folds now, right? It generates protein sequences you take hundreds of years. Humans will take hundreds of years to generate in 1 hour. So the entire thing is speeding up. processes. And so you have a company, whatever they do, the time between the execution of their work and output is probably maybe 10 days. When you leverage AI, you can do it in 5 hours. That's it. So for example, I want to run a startup. I don't need I don't need a 10-man team. I only need GPT subscribe for my website, for my mobile application, for everything. So now we're getting towards AI agents, where AI agent essentially is I have a company. One AI agent is my HR. One AI agent manages my backend. One AI agent manages my front end. One AI agent manages my content on my website. And I bring them together in an ecosystem and they do their work and I'm out. All I need to do is to what? Give instructions. Oh, you don't know. We have AI agents already, I'm sorry. Do you understand? And so you want to run a company now and it's entirely digitized, you don't need certain things. But people, the example she made about lots of data analysts in a firm, and I tell people, it's instructive because it will help. It will help you like determine a career path that is workable in some sense. I tell people, um, if I'm a data analyst at the moment, what I'm gonna do is I'm gonna just try to know how to leverage AI to get my results faster or to make my analysis faster. How does that make any sense? If you're running a predictive model, you want to create a predictive model based on certain data, right? Or you want to run some analysis. GPT can already do that. Okay? GPT can already do that. GPT-o1 can even do it better. But what do I need? And like she said, they will actually send lots of data analysts away from that firm. You probably just need one. And it's just time. If you get one person that can actually use GPT well, they won't need any. Just one person that can use it well and that can understand the results it brings out. So I tell people the best thing you can actually learn right now, if you're an analyst or anything, is just simple as something as simple as prompt engineering. If you're an analyst, right, something you really need to do is just learn how to use a model, get a model, how to fine tune a model, right, on data sets or on the task you want to do specifically, and prompt engineering. That's all. That's all you need to be an analyst. The reason is because you already have a better analyst. You mentioned doctors. GPT has, or particularly GPT-o1, has lots of textbooks that lots of doctors have never read before. And let me break it to you. There was a woman in the US, this happened, I think, a couple of months ago. For about 4 years, they've been finding out the diagnosis of her child, right? So they had gone to lots of clinics, they were treating different things. You know what she did? Just one night, she got into GPT-4, was it GPT-4, 0, or 4.0? She pasted all the test results they had done in the last couple of years. And she got a response from GPT. And you know what she did? She took the response to the clinic, the diagnosis the GPT gave her. And when they got to the clinic, they tested for it and it was correct and they treated it. And the child was fine. It was a tumor. The child was just fine. So they pasted the imaging results, the pathology results, every single thing that doctors were struggling to get in 4 good years. They got it in a couple of hours. Do you get it now? And so essentially, I was talking to a friend a couple of days ago that a medical doctor to be, and I told him, as a doctor, you have a system that knows something better than you do. Because how do you make your decisions? I look at some variables. That's how doctors make their decision. They look at variables. Oh, this is this volume. This is what I'm seeing on your X-ray. They look at everything together and they make decisions based on those variables. Okay. Yes, no, no. Okay. No, yes, yes. Do you understand? That's how they make their decisions. But then the AI does it better. It has much more reasoning ability than them at a shorter time frame. So what do they have to do? They just need to learn, okay, I need to get a model that is trained on what? numerical data, robust training. What I have to do is, okay, I'm specialized in um, orthopedics, or I'm specialized in oncology. All I need to do is I get data set from my workflow, right? Or the data set I get on my clinic every day. I fine tune it on this model. And so when I have some patients to review and everything, all I need to do is just to paste it there. And because we've achieved reasoning, I can look at the reasoning pattern and modify something I think is wrong in the reasoning pattern. So you're literally seeing the AI thinking. If it takes a particular diagnosis or it takes a particular result you pasted wrong, you can easily tell it, oh, I noticed in your reasoning process you took this as this. Can you please modify to this? That's what we're going to. That's essentially what we're going to. I have a professor I work with, Dr. Kingston, they're in Rwanda. So they're focused on oncology particularly. So they have very little oncologists in, I think, Rwanda. So the goal was to use, there's an app called Huron AI. And they have, I think they have their FDA or whatever approval already. Huron AI now is supposed to close the gap between oncologists and patients. So what that means is we're not just making those AI models oncology. No, oncologists are using them. So we have existing statistics of about 1 to, let's say, 20,000. But that one doctor plus AI can actually do this. And this has been pretty hard or difficult. But the one doctor plus the AI model can actually do this 20K faster and in a more convenient way while they keep on training oncologists to do better. So we get it. So that's what we're getting to. And it's a no-brainer because we already are there. So I'm going to go through this. Artificial narrow intelligence. Narrow intelligence was the likes of Alexa. Okay. Hey Siri, can you please call Femi? Apparently Femi is the boyfriend breaking up with people. Oh my god. Can you see? Siri is foolish. Right? Siri, I was never responding to you. I was never talking to you. Okay? Siri is not so smart because you could have figured out that I've been in the class since. So Siri is an example, very practical example of artificial narrow intelligence. Okay? Because Siri just did something really entirely foolish. So it's a narrow intelligence. Narrow intelligence means it's tailored to a particular task. It's just a voice assistant. It can't give me a good diagnosis of my patient or my children. Okay? So this is an example of a narrow intelligence. Ask Siri, um, all of them like that. They are called narrow intelligence because they are intelligent. They can figure out things on your phone, but they are sort of narrow intelligence. Then we have AGIs. We are currently at AGIs. There was a debate, I think, last year about when we're going to get to AGIs. And it happened sooner than we thought. So AGI is artificial general intelligence, where you don't have a particular model just doing something narrow, a specific task, but can actually do so much more. Can make inferences, can advise you, can think on its own, can just do lots of things in and of itself. That's artificial general intelligence. Do you think we should look at a definition? Let's look at a quick definition. Artificial, narrow, and general intelligence. You look back and really you'll be happy that, oh, I learned or I knew or I got to know this thing at this particular time. And so let's look at it. Artificial narrow intelligence, just some overview, designed to perform specific tasks, while AGI is designed to perform any intellectual task a human can. So anything intellectual that a human can figure out, AGI wants to ensure that machine can do better. That's the task. And it already is. And so capabilities, examples, and limitations. Right? Now, as at the time they trained BARD or whatever is powering Google AI engine, it says still largely what? theoretical, but it's not anymore. And that's the facade. People think certain things are never gonna happen until it catches up with them. And that's what we're getting to. It's not a scare in quotes. It's just a reality, right? If you are planning to maybe stay in a place like US, Nigeria is pretty cool. There's some things that will not come to Nigeria in maybe 15 years time, right? But you might necessarily not want to be here, right? You might necessarily not want to be here, so you may not be caught up in it. But yeah, it says largely theoretical. That is the limitations. But no, it's not theoretical anymore. I work in the AI space, and I know so many things that are already working that you don't need to, that are not out there. People are not using it. So, for example, before radiation therapy, medical physicists, right? Medical physicists, they are responsible for treatment planning. What does that mean? You have a patient with tumor. What we do is we try to control the tumor. And so we're delivering radiation, which are very, very, when they're excessive, they're very they can kill your body cells. So we want to kill the tumors without killing the body cells. So what we do is contour the tumors, right, based on their 3D representation, right? The medical physicist is one that plans everything. But now we actually have done a couple of things where you don't need a medical physicist to do that contouring of tumors manually. Just feed in the image, feed in the sorry. Oh, please let me call you back. I'm in a session. Let me call you back first. All right. Sorry. Oh, Jesus. Give me a moment. Oh, okay. Mhm. So yeah, so we basically can actually use deep learning, especially vision transformers, to sort of automate it. So you don't need a medical physicist for that particular task anymore. So with time, all of these things would phase out. So it's not theoretical anymore. We are there right now. So you realize even GPT is a form of narrow intelligence. But with O1, we're gearing towards AGIs. And let me just give you a task. If you want to know more about all of these things, just who knows Y Combinator here? Y Combinator. Y Combinator. It's a startup. Almost every Nigerian big startup is under Y Combinator. It's a sort of it's um I can like a VC firm, a venture capital firm where they fund startups, not just fund, they educate and train startups. So Y Combinator. So they talk about all of these things. Um, let me make it a bit practical. Um, Y Combinator. Just you guys just take out time to look at watch some of these videos, and you you get a global perspective on what's going on. And so not just limited to your own client. You get a global perspective on what's going on. And so you know how to like position yourself better for any of these things. I'm trying to look for a sample video, but yeah, let's take our time to just look through that. So what's SI? SI is super intelligence, right? So super intelligence is, and so, you know the problem people had is people thought all of these things are fictional, right? But the problem realizing that many of these things have become reality. I made a post sometime about transhumanism, and you think it's 666. So yeah, transhumanism essentially is, like I mentioned earlier when the class started, this is my hand. What my hand simply do is to take something, right? An individual, not me, an individual can modify his own body. Already they are already modifying their body, right? In the US. So an individual in a liberal society in quotes can actually remove his hand and fixing a hand that does more than carrying things. Okay? He can make a hand, a synthetic hand, and it's not fiction, I'm telling you. It's not fiction. They can make a hand that does so much more better things. A hand that does not need to carry a spoon can easily make a spoon. Right? But yeah, that's weird. But essentially, that's SI. So SI, one of the major part of SI super intelligence is um, let's let's look at something on that. So it doesn't seem as if I'm just saying fables because it sounds like fables. Yeah. So bad says it's still hypothetical, but it's closer than you think. Because I can extend reasoning thoughts more. It's closer than you think. So it says it's an hypothetical AI system that will be more intelligent than humans in every way. And do you agree with that? You have systems that are more intelligent than humans. You don't agree? Yeah? Okay. Do you agree? You don't agree? Okay. What do you think determines human intelligence? Exactly the brain, right? But if you isolate a human for 20 years, how intelligent will human be with the brain? Yeah, it's just what you know. That's what makes you an intelligent human being. It's what you know. The ability to contrast between different options based on. Hmm? Yeah, your reasoning is based on your exposure. Yeah. So that's why I say that's why Yoruba will say show lock only and he show say you cannot think. Say it to what? Huh? Prompt them. That's the thing. You might not entirely have to. But the whole goal is you want to be able to prompt them to do something. You want to prompt them to do something and advise us on what to do. So what I'm saying is you would actually prompt them, but you're not prompting them to just do something because they probably will know what you want to do better than you do. Right? So you want to get influence and advice from them. That's it. Yeah. Yeah. Mhm. Yeah. Mhm. Yeah. Okay. Okay. Let me explain something. People who do health here, you do nursing, right? Do you know when the first time your child identify your face, a child you give birth to, it doesn't identify your face for the first couple of weeks. It takes time to identify whoever's face, even in mothers. As after, it starts with the mother. Do you know how they pick up signals? You know, just think, maybe if you're careful, just say, how do like newborn babies recognize people? The voices, how they begin to, you can actually even try to study experimentally the formation of how they form faces in their early years, like when they're giving birth to, right? So it's the same way. Okay. By 1:30, okay, so I can be a bit faster. Okay, so you, okay, no problem, no problem. Yeah, no problem. Oculus is not super intelligent. Oculus is AI information with AR, um, um, augmented reality plus artificial intelligence. So it's a form of, is more or less like the early part of AGI. It's I can categorize it to ANI, narrow intelligence, but the recent re-event of Oculus, it's the early part of AGIs. Okay, but it's a combination of augmented reality plus artificial intelligence. So essentially, I was getting somewhere. All of people essentially learn from experience, learn from observation. That's how humans learn, right? So you can make machines behave that way. It's very possible. So just take out time to look at how young folks form faces and all sorts. And so yeah, we'll talk about this, and let's talk about open source. He has a very brief idea of open source. Open source essentially is all the things I did, right? But the model I built I make it available to the research community or to the engineering community to work on, to make better, to integrate for free. That's not open. OpenAI builds a model, make it closed source, and privatize it. And so what DeepSeek did was they made everything they did except their code base open source, available to other people to work on. And so we wanted to go through it, but we don't need to. We try to look at the history, the evolution of artificial intelligence. And then it's so funny that you realize that most of the things we build, the building blocks we have today, they are built on things in the 90s. Professors that worked on stuff in the 90s. In the DeepSeek model, there's something we call mixture of experts, which was one of the things DeepSeek utilized well. So there are two major models. Let's say, have you heard about Mistral? Mistral. Mistral is like OpenAI. It's a language model company. So Mistral basically already started using mixture of experts. It's a particular technique in artificial intelligence where I have I have 671 billion parameters. Now, it's a very large size model. The larger the size of the model, the larger the compute resource I need to run this model. If I have a 671 billion model, I probably need thousands of GPUs based on requests, people who are requesting to get outputs to run this thing, thousands of GPU. So what does mixture of expert come in? Instead of just a whole model, inside the model I can have 7 billion models, 7 billion parameters, a model, 8 of these 7 billion parameters, instead of just having this one whole. Now, each of these guys are experts in a particular task. Let's say math, let's say um, medicine, right? Let's say engineering, right? So each of them under this model, they are called experts. They are trained with a specific thing to do, but I combine them together. So much so that in this case, if I try to get an output, the reason why the model needs lots of compute is because when I input something or a text for it to process, it activates pretty much everything, all the parameters here. So because
Oh, testing, testing. Oh, testing.
it's that network that determines where exactly I want to send my input to. So if I send it to someone, I just need to send it to one math guy, one of the mixture of experts, without activating the other parts of the model. So with that, I have lesser parameters to run and lesser GPUs to use. That's what Mistral did. Mistral was one of OpenAI's largest competitors. Why? Because of one of these mixture of experts. So they were wondering how can OpenAI funded by 500, a lot of billions of dollars and stuff, and these little guys, you probably should check out Mistral. There's just some young guys that came together to do stuff, right? But then the essence of saying this was mixture of experts was in what? Came out in 1991. The paper that talked about mixture of experts in neural networks came out in 1991. And so many of the things we're building now, so they actually started pretty much a long time ago, but nobody really paid attention to them. That's what the DeepSeek team did. So we'll see further. And so the key players, you already know these guys. OpenAI, Google DeepMind. Google DeepMind are the ones I talked about that they are actually generating proteins will take billions of years. What does that mean? I want to ensure you get as much as you can. In genetics or in genomics, just quickly, the reason why somebody has a sickle cell disease is because, compared to someone who doesn't, is because when I run down the full genetic code of the person, the entire genome, a full human genome of the person, there is a sequence that's mismatched, right, in this person that makes this person a sickle cell, and is intact in this person that makes this person free from sickle cell. That's what this thing entails. Yeah, no worries, no worries. Sure. And so I'm looking at, let's say in Nigeria, the population here has tend to have tuberculosis easier. And then let's say when they're exposed to tuberculosis, they get tuberculosis, right? And then the population in Sweden, when they're exposed, they don't really get it. The reason why they don't is because of their genetic makeup, right? And so, and essentially these things are what? Proteins in the gene, right? They are proteins, amino acids, adenine, whatever it is, right? Those are health and fine. So what AlphaFold essentially do is they can actually find out, because a full human genome contains, I think, 3 trillion of data. It's like a full human genome, if you want to write it in a book in tiny letters, can fill up the whole of Africa. A full human genome. Okay? Just search. And so, for you to process this large amount of data by a human, it takes over 100 years. Full, this building, books. Just one person, a full human genome. Do you understand? Right. But then with artificial intelligence, AlphaFold, you can generate these proteins, probability of their occurrence, in less than 5 hours. That's what AlphaFold does. And it was a 25-year breakthrough. They were working on it 25 years ago, the AI team. And they had a breakthrough, I think last year. Their lead team got a Nobel Prize for it. Where we heading to essentially is, instead of doctors figuring out what's wrong in the population, we can actually use 5 hours to figure it out. So all I need to do is what? To do full human genome for Africans. Right? That's what 54Gene does. It's a company. Right? So instead of me just creating drugs now, I just create targeted drugs based on my understanding of their body composition of proteins. There are a couple of intricacies to this, more on this, but that's essentially one of the things we're using AlphaFold as Google DeepMind to do. And then Meta, you have Llama, you have PyTorch. PyTorch is, I write PyTorch. And then you have NVIDIA. NVIDIA, what does NVIDIA come in? I'm going to try to brush this based on this flow. We know NVIDIA, right? Do we know NVIDIA? NVIDIA. Hmm? It's not Chinese. Jensen Huang. Nah. Yeah. Does anybody know NVIDIA here? Okay, good. Who has a computer that has a GPU here? You have a computer that has a GPU? Huh? Okay, good. You have a gaming system. Let me see. Let me see. Let me just show you practically. Alright. So his gaming system, I want to see if, okay, his gaming system is powered by AMD Ryzen. That's NVIDIA. Okay, thank you. Okay, thank you. This is NVIDIA. This is NVIDIA. Okay. Beautiful. This is NVIDIA. Yeah. Oh, sorry. Yeah, can you see it now? This green stuff, NVIDIA. Yeah. Huh? Do you have virtual audience? Okay. You can just help me do that. So, yeah, what does NVIDIA do? NVIDIA is a GPU market. Reason is because when we run AI models, they are needed to run, let me not complicate it. GPUs they contain more cores, right? And they run in parallel. That is, you don't wait for one to finish before the other. So in some sense, we want to ensure that, for example, in CPUs, when you run, because we're dealing with numbers, numerical patterns, just imagine the 601 billion parameters, right? Those parameters are numerical patterns. So imagine you have 601 billion numerical computations you need to do. The reason is because AI is simply manipulation of matrices. Let me break it down. We've done matrices in secondary school, yeah, art or commercial or science, or you did matrices in math. AI fundamentally is we manipulating matrices. That's what AI is, right? So we convert text, we convert pictures, everything to an array of numbers, which is what a matrix, 2 by 2, 3 by 3, all of those things. And then we compute them at different levels through different algorithms. But essentially, we're basically manipulating matrices. Now, to manipulate those matrices at a given time constraint, you can't use a CPU for it because the CPU is not built to compute matrices at a short time, um, within a short period of time. So that's why we use GPUs, graphical processing units, and we use TPUs, tensor processing units, right? So essentially, what that means is CPUs are not actually built to run large amount of computation, especially numerical computation. And that's why we have to use GPUs, right? They are hardwares we use for training AI models. And not just those hardwares. NVIDIA has something called CUDA. CUDA is like a software optimizer. So it optimizes the numerical computation on the hardware. The reason why NVIDIA does better than AMD is not because AMD doesn't have a better hardware GPU than them. It's because they have an additional optimizer, right? It's called CUDA that they use for AI training. So that's where they come in. And so if OpenAI wants to, let's say OpenAI is running on over, let's say 100,000 GPUs. All the GPUs are coming from who? They're coming from NVIDIA. NVIDIA is the largest supplier of GPUs in the AI market. And so we see why exactly did it go down. Like you said, the stock market went red a few days after DeepSeek was released. Why? Because NVIDIA is a multi-billion dollars company at the moment. And so we'll see the reason why. Then we have China, DeepSeek, Baidu. We have Quen. Quen is like the open AI ChatGPT for Alibaba. Right? We have Kimi and a couple of other people. And then in Europe, we have DeepMind, Mistral, Aleph, Alpha, and a couple of other ones. And so DeepSeek essentially, um, not just a model, is a company. And a bit of context, DeepSeek was started by this guy, Huang. I mean, is it Huang? I've forgotten his name, sorry. But it was started last year by a quant trader. The guy wasn't even an AI guy. He was in finance, was in quant finance. So he learned how to use AI models to like for his financial workflows, and then he made tons of shit money. And so in 2023, he decided he wanted to set up more GPUs. Was it 2023 or 2022? He decided to set up more GPUs in China to expand whatever he wanted to do. He wanted to do core AI work. And so he bought lots of NVIDIA is it H100 or H800 GPUs? He got lots of them, I think in 2023, which was essentially how DeepSeek started. And so then a problem happened, something happened. Last year, the US, in a bid to examine their competition against China, they stopped all importation of GPUs, especially NVIDIA H800 GPUs to China. The reason was because, yeah, they were trying to exert dominance. Now, you know what, this AI race, because they know what it can actually cost. This AI race, we need to lead it. And to lead it, we need to stop the importation of GPUs to countries we believe they can use it for. In quotes, US always says other countries use it for crazy things or unethical things. So they tell you, oh, Russia is fueling nuclear, whatever. They have their nuclear plants. I mean, US. So essentially, they stopped the importation of GPUs to the US. So that was why this guy, the CEO of DeepSeek, was limited to only about 22,040 GPUs he had gathered a couple of years before. That in 2023. That's essentially what DeepSeek is about. And so what happened was, where the whole rave came from was, NVIDIA has access to over 100,000 GPUs. Over. Um, Grok, Elon, he has a factory that has about 100,000 already. And they consume about, I think, 1 megawatt, I think, per day. Right? But it shows you that OpenAI actually has more. And so just imagine OpenAI having over 100,000 GPUs and somebody having 2,040 GPUs. And whatever they did outperform this guy. It's crazy. That was where the problem started for NVIDIA, which I have my personal reservation about that. But the problem about NVIDIA is, if OpenAI can actually, if DeepSeek can use less GPU compared to 100,000 GPUs, right? Why exactly am I buying a lot of GPUs to start to start any AI company? So lots of investors thought there was no future for NVIDIA. So let's pull out. That was why the red in the stock market happened. So there was a lot of, you know what, the demand is an illusion. That was the problem. They believe the demand for GPU, so there was a huge rising demand, right? Because Trump had already, there was a $500 billion fund already to accelerate AI development. Where do you think the $500 billion was going to? At least half will go into hardware. Yeah, at least half. So imagine a company heading towards, let's say, $200 billion market. They are not approaching it, it's coming to them. Do you understand? So people thought, fine, if they thought NVIDIA was going to do well, money was coming and everything, but we observed that we actually don't need a lot of GPUs to make complex AI systems. And so people were skeptical, oh, if this is it, then it's a pending disaster. So let's just pull out. There was a lot of skepticism in the market, and then everywhere turned red. I'm talking about language models. So yeah, but before R1, just quickly, before R1, the latest one they released that outperformed GPT, DeepSeek had been building a lot of stuff beforehand, right? It started from DeepSeek V1, that was throughout last year, and it could amaze you that it's just some bunches of undergrad and some bunch of PhD students. And it informs that you don't need too much to make something work. That was one major thing we learned from it. You don't need too much to make something work. Just try to build from ground up. Try to build from ground up. And so, let me show you something. Let me show you something. I made a post about something to give you like a better context. All right. We're rounding up soon. All right. So there are three things we want to focus on. So I made a post here on the DeepSeek paper. So AI research basically you read a lot of papers. That's where you find out some of this complex stuff. And so I said it proves to the entire research community that innovation is not solely in the hands of big tech companies. Right? Let me tell you something. 2014 GPUs. DeepSeek trained V3 for I like showing people DeepSeek V3 paper technical report. Good. At least something you learned today that I learned how to look at a technical AI research paper. Let's look at this. This was what caused Wahala. Can you see something? The total amount of GPU hours used in training this model was 2,788 K is thousand. So 2,788,000 GPU hours. How did they calculate $5.57 million. 2,788,000 divided by, because you have 2,048 GPUs. This hours is collectively on this. Okay, so 2,788,000 divided by 2,048. Let me make sure I want to, because let's calculate it ourselves and find out how they were able to get to that cost. Divided by 2048. Sorry. 2 million. Sorry. 788. How did I calculate the other time? Hours divided by uh, 24, right? Yeah, GPA hours. Divided by 60. How many hours take one day? Wait. We have 24 hours in a day. So it's in hours. So let's make it a day first. That's why we divide by 24. That's 116, 166. Then let's make it a month divided by 37 days. And then divided by a month is 30 days. 5, 6 is 10 times 2, 48. How did I calculate this thing? Whatever calculation I did amounted to about 5.6. Wait, let me take out time. 2788. Yes, 2788000 hours. 1 hour, 1 GPU hour is $2. Okay, the amount it costs to train 1 hour on any GPU is $2 at standard price times 2. That's how much? 5576. Okay, that's 5576. That's how they got to $5.56 million. So the entire time they choose. So how many hours does it cost to train on one GPU? Let's take 2788000 divided by 2048. So it takes about 1361, 1361 hours to train on one GPU. Let's convert that to a week. Yeah. Divided by 24. That's 56 weeks. I mean, a day, sorry. 56 days divided by, how many days make a week? 7. 8 weeks. That's about 2 months. They spent 2 months training a full V3. V3 was their foundation model. R1 was the one they released, was built on V3. Okay? So you see that they spent 5.6 approximately million dollars training their AI model across 6 months. We speculate that OpenAI spent $100,000, no, $700,000 a day to train their models. 700K a day. In 2 months. 2 months, let's say 60. Try to get a cost. Yeah. So much. That's it. That was what DeepSeek did. They were able to innovate in such a way that it compresses the amount of GPUs used to train their model. Yeah. GPU, it's a graphical processing unit. Graphical processing unit. The same way your computer has a CPU, central processing unit, right? your computer has a GPU, graphical processing unit. The essence is the games you run, right? The graphics it renders, they are enhanced graphics, and enhancement of graphics is based on numerical computations. For me to make a picture sharper, all I need to do is to add what more pixel, numerical pixel together, right, across a particular dimension to enhance the image. So when graphics entirely is basically numerical computation, and so the numerical computation you run at each frame when you are playing your game, right, and then it runs smoothly, cannot be run on the on a CPU. It can't run on a CPU because CPU doesn't have cores, CPU cores that can run those things well. They are limited and they don't work in parallel. That is, it has to wait for something to finish before it starts. But GPUs are built with multiple cores, better cores that can manage all this numerical computation. That's why you have graphical processing units. Okay? And so I'll try to round this up quickly. And so there was a post. Just lastly, the three major things that made it stellar compared to OpenAI. You have chain of thought reasoning, like I mentioned earlier. Chain of thought reasoning was not implemented by DeepSeek. It started in 2022 by J-Way, right? It wasn't DeepSeek that innovated it. But the whole idea is you're able to pick one or two things, right, and added them together to optimize their own work. And they found out something new. And so GRPO, Group Relative Policy Optimization, what does essentially mean? Okay. Almost done. What that essentially means is there's something called reinforcement learning in artificial intelligence. It's a way of incentivizing an AI model to learn itself. For example, we normally do what we call supervised learning, where a human is in a process, in the data, right, and making the machine understand, okay, this is what you did wrong. This is the output. Correct yourself. But this time, reinforcement learning, you don't need a human to correct the AI model. It corrects itself. So what the system basically does is it rewards the AI model for correcting itself when it does correct itself well. Okay, that's reinforcement learning. Essentially, is the AI model learns to what correct itself. But reinforcement learning costs a lot. It costs a lot when you're training with it. It uses a lot of GPU. But this particular optimization halved the cost it takes to train on reinforcement learning. Okay. That's GRPU. And then lastly, it calls something knowledge distillation. So you have these 671 billion parameters. If I want to save you, let's say I run OpenAI, I run no, OpenAI, and OpenAI has 671 billion parameters. And we've learned that the larger these parameters, the larger the size of the model, the larger the amount of GPUs you need to run that. The larger the amount of GPUs, you also need to save you your output. Let me break that down. In the GPU market, you have the training market, you have the inference market. Training market means you need a lot of GPU to train a model, right? But when you've gotten that model, the parameters, right? Every response you send to ChatGPT is sent to a server that contains that model and GPUs. When the server gets the input, it uses that model, it activates that model, right? And then uses the GPU to enhance the performance and gives you your results. So that means it uses GPU when it wants to give you a result, not even just training. It's called inference. And so if the parameter size is very big, it will affect, and you don't have so much GPUs, it will affect how fast you get what your outputs. Because if you don't have enough GPUs to run that 671 billion parameters model and give you an output, it won't work. So the inference market, that is when you're serving the model to the customer, because what you're doing on GPT is you're being served the model. The model is taking an input and it's serving you the output. But you can't run the model well, right, to give you an output if it does not have enough GPUs. And so what they did was they distilled the 601 billion parameters into 7 billion. Okay? into 7 billion. So instead of running 7 billion, all right, all right. So that's essentially knowledge distillation. So let's um one day come in, and so you can give us more, just like a roundup details on this. There's a lot. There's a lot on this, but before it's coming, just taking some seconds. So that's it. They distilled a 671 billion parameters model into 7 billion. From 671 into 7 billion. I'm not going to go into the technical details around knowledge distillation, right? But what you just need to know is we were able to take a 671 billion parameters, large size model, distill it to a small size model. And so when you need to run inference on it and get output, you don't need so much GPUs in quotes. Do you get it? That's one big thing they did. And one funny thing they did was they realized that the 7 billion parameters model did better than 671 billion parameters model. Yeah. So yeah, give me a second. One day. Yeah, yeah. You want to ask a question? Mm, okay. Yeah, yeah, I'm here.
Don't tie yourself to one or two. This man wants to set you up. It depends on what you want to use it for.
So I showed you a benchmark that look at this benchmark. So you see the performance of each model particular to a task. So if you want to do Chinese or Arabic, one is better than the other. If you want to do Korean or you want to do math or coding, one is better than the other. So just like I said, it's just particular to what you have.
So yesterday, Elon Musk said that Grok, the new version of Grok, is coming out and it does better math than ChatGPT. So again, it really depends on what you want to use it for. If their own selling point is the math, then you go and test which one does better math. Some are more intuitive than the others. Some are more sensitive than the others. So it really depends. That's a very tough question to say if you were given one, which one? I would say use everything, but for what? Do you get? But as we go along in this lecture, in this conversation, you get to understand um, DeepSeek, Gemini, um, ChatGPT. You get to understand the difference and which one you. Good afternoon, everyone. My name is Wande Adams. I'm the co-founder and CEO of the Bowl of Africa. But today I serve as your co facilitator. I already see that your hand is up. What was the question? Simple way to use AI to make money. All right, we're getting somewhere now. Those are the kind of questions I like. That's why I'm here. Actually, I'm not here for all the technical. I'm a businessman. So let's talk about the real deal. So today um you guys have discussed AI at length, right? You've gone through definition. Have you gone through evolution of AI? Um, do you guys know what kind of gave AI its first how do I put it now? Um, its first boom, and everybody's like, "Oh shoot, this thing works." Do you guys remember? Can you remember any story that made? What story made you feel like, "Oh man, this AI thing is here and it's going to disrupt the world"? Do you guys remember any story that reminds you of anything AI? So AI was a theory for a long time. In the 90s, they started thinking of artificial intelligence, right? Then eventually eventually we got to the space of generative AI, right? But there was an incident that happened a couple of years ago when AI went from being theory and math theory and all this theory and coding theory to reality. And what really happened was IBM's Deep Blue defeated a world champion in chess. An AI algorithm played chess with a world champion and beat that world champion. And that was the first time people are like, this is not just theory, this is real. Because now robots can think and outsmart a genius. Because we didn't just pick the average guy. It's not like you trying to play FIFA on your computer and you're just playing the computer and you just be beating the computer anyhow. This is now a robot that is playing a world champion and gets defeated. So now AI models are now challenging human decision making across several industries. To the point where you now have situations where we human beings maybe don't even trust our own gut anymore without cross checking with artificial intelligence. Right? And so where we stand today with AI is that um, we have some key players, right, with global influence. Can you please tell them to reduce? We have some key players with global influence. Players like OpenAI, DeepMind by Google, Meta, and then there are some other ones like Anthropic and Mistral in Europe. But then what's now happening is that there's a move in Asia through China. There's an alternative AI push in China, and that's where DeepSeek comes in. And now everybody will be talking about DeepSeek, 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 DeepSeek. The biggest thing that scares everyone about DeepSeek is because it aims to create an open source that is alternative to OpenAI. Now, um, before we get to opportunities for Africa, I'm just trying to lay the foundation. So now let's bring it back a little bit. What does open source mean? Did you go through that with them? So we all know what open source means now, do we? So now, what that tells you is that a lot of the AI that you've been interacting with was built on something that had already been built. So, for example, ChatGPT is just a product of OpenAI, right? Sora is just a product of OpenAI. It's the open source solution that I can go and build on top and give end users an AI solution, right? So maybe what we understood before was there was Gemini for Google and there was ChatGPT, and they were competing at that level. And so if DeepSeek came out as an alternative to ChatGPT, maybe it wouldn't have been a big deal. But DeepSeek came out as an alternative to OpenAI, open source, right? And it is fueling competition because before DeepSeek's open source, there was very high demand for OpenAI solutions. Outside of that, OpenAI relies on, did you guys cover GPUs and NVIDIA and co? OpenAI relies on NVIDIA chips, NVIDIA GPUs, right? And whoever wins this race for AI gets to gain dominance in a lot of aspects. Because remember, imagine us saying, let's just use an example. Let's go back. Remember that example of AI being a world champion in chess. What that means, so if you leave it that way, what that means is, imagine if every country in the world, or top countries in the world, top 20 countries in the world in chess go to a chess World Cup final, right? And Nigeria brings Philip, right? Philip is number one in Nigeria. It's the best. He represents Nigeria. The US brings a robot to represent them. The robot beats everyone easily, just like that, because it can anticipate anybody's moves. It thinks faster than anybody. It does all that. What does US have in that competition? What do they have? Hmm? They have an unfair advantage and dominance. That's what the US is bringing to the table, an unfair advantage and dominance. And that's how it's going to be by the time they start to use artificial intelligence for wars and cold wars and competition in the market and all of those things. Whoever leads that race is going to have dominance and unfair advantage over the other. And that's why it is a big deal. And that's why you're seeing that governments are getting involved. Right? Now, what is happening here? The US had a Chips Act about 4 years ago, 3, 4 years ago, where they decided to invest in chips. Okay? And from there, a lot of drive goes into, building GPUs. These GPUs are now being used for AI, AI solutions. And then we get to the point where China wants to participate in this space. The US wants to participate in this space. NVIDIA, as a GPU manufacturer, became a $1 trillion company in a very short while. But they had some sort of monopoly on chips. What then happens? The US regulates NVIDIA and reduces how much chips they can export to China. So, are you guys understanding the fight now between everybody's looking to gain an advantage? So, if I have the raw material, I might as well limit it, because why do I want to make something available to Philip to come and defeat me? Right? So China starts to invest heavily in AI infrastructure. So what that means today is that AI is no longer just technology. It is no longer just theory. It is now a geopolitical tool shaping the future of economy and military powers. So let's just keep this foundation, because where we're really going is, what does it mean for Africa? But we need to look at what it's been doing in the West and in Asia, right? So, like I said, the role NVIDIA plays in the AI revolution. NVIDIA dominates AI chips with GPUs A100 and H100, right? And it's the backbone of AI and its inferences. So for that reason, AI's shares, I'm sorry, Nvidia's stocks keep going up, right? Nvidia stocks keep going up. And um, what happened recently with everything that you're learning, DeepSeek then makes an announcement that the use of these GPUs and the amount that is being used and the amount of revenue that is being generated. Because you have to understand, when people invest in something, they don't invest it for what it's doing today. They invest in it for its potential, right? Because they are expecting return on investment down the line. Are you guys with me? So if Nvidia is doing so much today, the possibilities of artificial intelligence, I don't even know that we've gotten to 30%. And if at that today, Nvidia has become $1 trillion company and is doing very well in the stock market, it means that the growth of Nvidia is endless. The growth possibilities of Nvidia is endless. Are you with me? What then happens? DeepSeek comes out and says, hey, what our competitor in the US is doing and spending so much money doing, we've come out and we've now done it for a lot less. So maybe Nvidia's projected revenue is not what it's supposed to be. What happened? 3 weeks ago, 4 weeks ago, Nvidia stocks crashed because of this findings. But what people didn't keep in mind is, and I don't want to disparage one platform over the other. But remember that the US government has sanctioned China and have regulated Nvidia for what they can sell. So where we are today is that what OpenAI is using and the chips that they have access to, China is not there yet. So just keep that in mind. So that's that's the battle, right? Whoever wins the AI race is going to have economic dominance and unfair advantage in military power. It's just that simple. So what does this mean for Africa? As far as, and I'm going to come at it from two different angles. As far as technology growth for the country, for the continent, and economic empowerment and investment opportunities for the continent. So the risk, right? Because AI is now a battleground in global dominance. So things like nuclear technology and Cold War, now when they've had it in the past, it didn't include artificial intelligence. Going forward, these things will be considered, right? So what does it mean? The first thing is, let's look at the risk. Africa, the number one risk is that Africa is currently depending on foreign AI models. We don't own a foundational AI model yet. You know what that means? It means that for Africa, if we're to do anything today,